Welcome back, everybody. Welcome back to the channel. This is going to be part 2 of how to compile a superclass. There might be a part 3. I have to see this video. I mean, there's still a lot of stuff we have to go over, so let's just kind of see where we go from here. So, as you remember, we talked about before in the previous episode how to compile a reference pointer. Now we're getting ready to actually resolve the reference. So this is going to be the first piece of code where we're actually going to see in real time how I actually resolve things in the language based on whatever I've been passed. So what you want to do is pass in the AST and the reference to the reference pointer, and that's going to return a class object. So if I go to this function, so as you can see here, resolve class reference, we pass an AST and a reference to the reference pointer. Now there's also an allow generics Boolean, and this is by default set to false. So that's the default value in case some of you guys are wondering. And what that'll allow us to do is basically just allow for resolving of generic classes. There's going to be a reason why we need this. We're going to see it later on in the compilation process. We don't really have to care about it for now, but it is important for you to add it. So we're going to have two main cases. Now let's start with, I typically start with the easier one first when it comes to actually writing the code, and I go to the harder one. So what we're going to do is we're going to say if pointer.class is a singular, what this singular function does is just checks to see if the len is equal to 1. I was too lazy to just write if the size of pointer.class is equal to 1, so I created a function. So after that, we want to get our class by saying resolve class. So we've already gone over this function already. So we basically want to just take this code here and pass in the module of the pointer. And again, if it's empty, then this get module will just return null, which is totally fine. And we just want to get whatever module we're going to be referencing from the code obfuscation system. And then we want to pass in basically classes get at 0. And the concept of this is if we wanted to resolve a class of, let's say, string, well, string is technically going to be a singular um, reference pointer, meaning that we don't have a module or anything like that. So, and whether or not we have a module doesn't matter because we'll just access it from here. Finally, you want to pass in the AST and get whatever's returned. So with that, we want to check the value, right? So obviously ignoring this, right? Ignoring if the fact that it's null. If it's not equal to null, great, we just return the class. And therefore, we've actually resolved whatever we needed to find. Now, if it's not, and it turns out that it is null, then we want to get our class by locating the class based on whatever module we passed in, and we still want to get the name of the class, of course, but this time we basically want to add these less than and greater than symbols to the end of the name. And we want to check the generics class list. So that's where we do that. And of course, if allow generics, what we're going to do is we're going to say this is for, oh, okay, so I guess I explained it. So this is for extension functions. That's why we end up doing that. And basically, if allow generics are set to true, then we'll return the class. Otherwise, we'll say whatever the name of your class was, it was found to be a generic class. Have you missed the key parameters of the class, perhaps? So we just want to let the user know that, hey, this is a generic class. And if we're not allowing it, then we want to notify them. Otherwise, we'll have another case. We'll have another case where, let's say it's an alias, right? So we're going to assign an alias. We're going to assign this variable here. We're going to say that's equal to the current scope dot class dot get alias, and we want to pass in the name, and we want to set check base to true. And what that's going to do is that's going to basically just go up to all the levels and try to locate an alias. If so, then we obviously, like if this value is equal to null, then we want to go to the next case where we try to resolve the alias. Now, what this is going to do is this is going to be a more complicated way of trying to figure out, does this alias actually exist? So what we're going to need to pass in is we're going to need to pass in the module that we're referencing and then the class name and the AST for error reporting purposes. Now, if that, before we jump into this function, if that is not equal to null, so if either of these values are not equal to null, then we're going to go inside of this code here. And what we're going to, and we want to do two things. We want to compile the alias type, and we want to validate the access, and we want to do a simple check where we check to see if the alias type is equal to a utype class. If so, then we want to return whatever that class is referencing. Otherwise, we say symbol whatever is not a class, and we just convert the utype that the alias is referencing to a string. Now, if we've tried all of these, then we're just going to say could not resolve whatever. So let's go into the case where we try to resolve an alias, then we'll go into the other code as well. So when we want to resolve an alias, here's how we do it. If we basically pass in the module as I showed you before, the name and then the AST. So we're going to create a list of global classes. And we're going to resolve the class based on the name that we pass in here. And we're going to pass in the global classes as a list reference, so that way when we get the value, this list is populated. Then we have the module that we're going to be referencing global class, which is basically going to be SRT global. So we're going to be accessing all of the SRT globals in whatever module that we're currently in, and the AST. Now what this resolve class function does is, as you can see here, we pass in the classes list that we want to traverse, we pass it the results list that we want to populate, we pass it the module, the name, the AST, and match. And I don't think we've gone over this before, so let's just quickly go over it. So we want to check to see if the module is not equal to null. If so, then we want to say class is equal to find this class at the module name, classes, and match. So whatever the classes list we passed in here. And as you guys remember, match is used for locating classes that are around the similar name. The match Boolean will only be set to true if we have not found the class yet. So it's set to false by default. But if we could not just locate the class, then we'll use the match Boolean as a way to basically locate a certain amount of classes that are similar to that name to let the user know that, hey, maybe you meant this class. So what we're going to do is, if the module is not equal to null, then we want to find that class, and this function we've gone over before, so it calls this function specifically, if any of you are wondering. And then we want to validate the access of that class. This is the same function that we've gone over before as well. We just want to make sure that we have access privileges to that class. After that, we basically add this class to the results list, and we basically just return out of the function. And we're going to return at the very end, we're going to basically return whether or not the results is empty, so it's going to return a Boolean. Now let's go to the case where we actually look for, or we try to locate a certain amount of classes based on the values that are provided here. So what we do is we basically do our standard location of the file. So we try to locate the file and get the import map that that file has. The idea behind this is we want to basically try to locate all of the classes that the current file is importing. So once we get that import map, we basically get the reference to the list, for loop through that list, and try to locate the class based on the name that we passed in each module, right? So if you have std, we want to locate all of the classes of std module that have this certain name. And then every time we find a class, we basically just try to add that class. We call add if just to make sure that we haven't processed it before. And that's it. And then of course we break out of there once we have processed, or once we've found the appropriate file. Once we've done all of that, then we can go back, and now we're ready to resolve our alias. So we want to for loop through that, and we want to for loop through the classes list that we were provided as a result of this function. And we want to try to resolve an alias. So we're going to get that class, and we want to just get the alias based on the name, and we do not want to check the base class in this case. And if we've located that alias, we just immediately return the first alias that we've resolved. So again, this is where it comes down to the user to, if they're going to have a global access to something where they just blatantly say they want to access a certain class or a certain field, it's up to them to basically denote what module that the field or class is inside of, because there's a potential that we could be returning them something that they weren't intending for us to return. So if we go back after that, we want to compile the alias types. So basically what we do is we check to see if alias is not equal to null. And as you can see, the purpose of this function is to forward process a field's type and value if it has not been processed yet, to prevent weird, incorrect, undefined behaviors with the compiler. So this is going to be one of the few things, and sorry if you guys hear rain in the background, it's currently pouring down where I am. But as we're looking through this compiler, you guys are going to notice a lot of these compile functions. And the idea behind that is this is exposing some of the magic behind my compiler. The way that I do this, and I do this everywhere, the way that I do what's called, and I made up this name by the way, I do what's called an on-demand or just-in-time compilation system. Just like a JIT and a virtual machine, I've made my own system that works perfectly where I basically compile things just in time as they're needed to be compiled. So the only reason that I am now compiling this alias field is because I'm now using this alias basically as a superclass, and I'm inheriting that from a different class. So if class X wants to inherit this alias, I need to compile the alias in order to get the necessary information from it that I need to. So this is something that's really cool. Now, this compilation process is a little bit later on in the compilation process, and we will see this function later on, so this is not going to be the last time we see this function. So I will not go over this because the video will be too long, and it does a lot of things that we just haven't built yet. So if you guys want to, you can just kind of copy what are the basic things I have down here, but I will go over this function at a later date. So assuming that we've compiled our alias type, and you just want to create this function, by the way, because once we actually go into this, you want to have this function present. So all these functions that I'm mentioning where I say created, but we're not going to talk about it right now, definitely create it, but just know that we won't be getting to it for a while. So if we go back, once we do that, then we want to validate the access. Now, this is going to be a little bit different than before. So this validate access function, like I said, I have a couple of them, and you're going to want to need to create a couple of validate access functions. You're going to want to create a validate access for fields, classes, which we already have, and methods, which we don't have. So we will, like I said, go over this as things go on, but I'm pretty sure the code in here is basically almost the same as everything else, right? So if we look for validate access of class, I'm saying invalid, like if it's a local, right? And it does not have the local rules, whatever rules denote that it's a local, I say invalid access to localized whatever. Same thing up here for field. If it does not have the appropriate rules for local, I just say invalid access to localized whatever. All I'm doing is just changing the way that I access the information. So if you guys want, you can do a search in my code for validate access if you want to be proactive. Either way works, it doesn't really matter, but create this, and we basically want to check to see if the type of the alias, so we want to say alias.utype.getType is equal to utype field, utype class, or utype method. So if we're dealing with either of those types, we want to basically validate the access based on which type that we have. So do that, and once we have all of that code, then we're going to go back here, and we want to basically check to see if the alias type is equal to a class and return that class like I mentioned, and of course error out accordingly. So once we've done all of that, we're now ready to start processing the case where we try to resolve a class that has a hierarchical structure. So what we're going to do is we're going to say class, we're going to resolve the class by passing in the current module or the module that is in the reference pointer, the name of the class in the AST. Once we get that class out, then we want to say if class is equal to null, then we want to try to locate this class. So what we do is we first try to see if we can find the class by passing in the module as per the reference pointer and the name of the module, and then we append this to the end, the less than and greater than symbol, and we search the generics list class. If so, then we say could not resolve whatever, it was found to be a generic class. Have you missed the key parameters? Now, the reason why we want to do this versus not immediately checking for allow generics is because even though I can allow returning a generic here for resolving a class reference, we don't want to do that if we have our example where we have this right here where we say foo dot list dot, right? Like if this list class had another class in there called foo class, right? We still want to know what are the types of the list class, because otherwise this doesn't really make sense from a compiler perspective. So once we do that, then we basically want to have another check where we say if we can find the alias by, now this is the exact same code that we had previously that I just showed you guys. So we want to find the alias by getting it in the current scopes class, or we resolve the alias in the same way that I showed you before. And if either of those are not equal to null, then we want to compile the alias type, validate the access. Then we want to check to see if it's a class. If so, we want to set class, which if I go here is this same local variable. We want to set this local variable to whatever the class of the alias is. Now, if get class is only going to return true if the alias is a class, right? So the idea is that since we know that it's a U-type class, we know that it's not going to be null from this get class function. After that, you want to just jump to resolve class hierarchy, which is right down here. Otherwise, if it's not a class, we want to say symbol whatever is not a class. Otherwise, if we just can't resolve it from these two methods, then we say could not resolve whatever. So now we're at the case where we want to resolve the class hierarchy. So what we do is we create a U-type, we get the name based on the last element in the class's list. So here's how this kind of works, right? So if we have, I don't know, let's say class of foo, and then dot foo class, and then dot apple. I know, great names, right? So what we're going to do is the way we access it is we first want to compile foo because we need to have a basis of where to start. Then we want to take this apple class and we want to pop it immediately off the list. And once we do that, we're basically just going to like put apple to the side. And now we want to process foo class. So this is kind of what you're seeing right now of how I'm actually doing all of this. So if I remove this code here, we can see that after I pop it back, which would be the apple portion that we just saw, I check to see if the pointer's class.size is greater than 1. The reason why you want to do that is because in our example where, here, let me just do this. In our example where we have foo class dot apple, if it's greater than 1, that means that we have another class after the foo portion, right? But if we only had the foo and it was foo dot apple, then this would be equal to 1. So if it's greater than 1, if we have the case where we have foo dot apple or foo class or whatever, then we want to do what's called a retain scope class. Now what this does is it's going to give me a highlight here. Right, so what this is going to do is we're going to basically get or save a old scope class, and we're going to set that value to whatever the current scope class is, and then we want to set the current scope's class to whatever the class or the new value that we pass in here. And then after that, for restoring, all we do is we just set the current scope's class to the old scope class as created by this define statement. And this is a great way to basically modify scopes without having to push and pop the scopes, because sometimes you don't want to push and pop scopes because if you remember scopes, the actual scope reference has a lot of information. It has what function we're in. It has information about our class, our blocks, what type of block that we're processing, and tons of other information. So sometimes you don't want to actually push and pop scopes. So this is a hack for us to not have to do that. And we want to call resolve class hierarchy. Now, this is a big function, and I hate to do it to you guys, but we are going to have to talk about this later. And the reason why we have to do that is because this function is actually worse than the other ones because it involves code creation or code generation. And as you can see here, I'm using the opcode builder that we haven't gone over yet, and I'm putting an instruction of move G, and I think it has some other instructions in here as well. So because of that, and because we don't have a virtual machine, it doesn't make sense to talk to you about code that is running on something that we haven't created yet. So just create this resolve class hierarchy function, and let's just assume that this function is just going to work. So what we do is we pass in a data entity, whether or not we're coming from a class. So let's say we're resolving a class hierarchy from a field. The from class variable basically denotes, are you coming from basically a static scope type? Meaning that like if you have, a field, that's obviously an instance. So if you say, some field dot whatever, you're accessing an actual instance variable. Whereas if you say like string dot whatever, you're accessing it from a place of an absence of an instance or a static scope. So hopefully that made sense. After that, you want to pass in the reference pointer, the utype, and the AST. So let's assume that works. And once we do that, then we want to otherwise, so if we have the case where we just have the foo, and basically meaning that the class's size is equal to 1 after we popped the apple off, then we want to just set the utype set the type to a class, and set the resolved type equal to the class variable. Now, we're going to do a check to see if the utype.getType is equal to utype class. And the reason why I want to do that is because this resolve class hierarchy, we're passing in the reference to this utype. It technically might still not be a class. So that's why we do that. We want to set the class local variable equal to the get class, or whatever the get class function returns from our utype, and set our subclass equal to this value, and we say class.getChild class of name, and we return that if it's not equal to null. Otherwise, we try to get the child class by appending these values, and if that's not equal to null, if we allow generics, then return it. Otherwise, print out the same error that we showed above. Otherwise, if it's neither of these, we say could not resolve. And of course, if it's not a utype class, we say symbol whatever is not a class. So the way this works is whether or not we call resolve class hierarchy, like if we have the example where we have foo.apple, right? We're basically going to have up here, we're going to resolve the foo portion. And that's the class pointer is going to be set to foo. Once we come down to here, we're going to jump to class hierarchy, and we're going to say our name is equal to apple. We're going to pop apple off the list. Now the pointers.class size is equal to 1. We're going to skip this if statement. We're going to set the utype to a class. And we're going to set the resolve type equal to class. The reason why you want to do that is because that now sets the utype that we resolved as the initial value to the class that we want to access as a parent class. So when we call, class.getChild class of name, or in this example, apple, we're calling getChild class on the foo instance of that pointer. So hopefully that made sense. And it's the same way with this as well. So we do all of that. And once we have finally jumped out of this function, we do some final checks to make sure that we haven't shot ourselves in the foot. Now, this is going to be the last code that we're going to go over for resolving a base class for this function. And then we'll probably have another like part 3 and a part 4 just to kind of split things out even more. But we want to basically check to see if our base class is not equal to null. And here's a very important part. This makes sure that we don't have any circular dependencies when it comes to inheriting things, because you can actually break the compiler if you have a circular indefinite dependency, because the compiler is just going to keep looping through all the classes that you inherit to try to resolve any of your information. So we want to basically check for our current class and see if our class is related. So if we pass in the base class and the class is related, that means that this class, the only way it's related is if the class has been inherited before. So we don't want to create if you ever seen like a picture where a snake is eating its own tail, that's basically what it's going to be like. And then after that, we want to do the flip side, where we want to check to see if the base class is related. So it's not enough to just check to see if the current scope's class is related to the base class. We also want to check to see if the base class is related to the current scope class, just to close the loop so that we're all good. And if either of these are true, we want to say generic error. We want to pass in the AST, and we want to say cyclic dependency of class of whatever. And we want to, again, make sure we pass in that full name in parent class of whatever. So we want to make sure we pass the base's full name and the full name of the current scopes class. Otherwise, if the base class is in fact an interface and the current scopes class that is in fact inheriting this base class, not an interface, then we want to say class whatever cannot inherit interface of whatever as a base class. And here's where we get to our first example of actual code examples of the actual code. Here is a way for me to basically show the user exactly how to write the code correctly with inside of an error message. It's really cool. So the reason why you want to do this too, by the way, is because you can't inherit an interface as a base class, but interfaces can't inherit other interfaces as base classes. So it's just a programming construct. So I say class, and I pass in the current scopes class that we're using to basically find the base class or whatever that class is inheriting. And then I say base, whatever the base class of this class is, and then I put the colon here, and then I say the name of the base class that we're inheriting, and then like a little block example. So hope you guys like this. This is really cool. I thought it was a nice thing to add to the language. Finally, we just return base, and we're done. So once we do all of this, then we have a lot more to go through. So We're gonna stop here. After this, it's pretty lightweight. It's not much more work to do. We basically just want to do some final checks for interfaces as well as enums, I believe. So we're gonna stop here, and on Wednesday, we'll finish up on this code. And once we're done with all of this, then we're gonna start working on our virtual machine. So there's going to be a couple of things, and that video is going to be on Friday. So definitely look out for the video on Friday. And of course, if you guys have any questions, definitely put them in the comments section below. Also, if any of you guys are interested in helping out the channel, definitely head over to my GitHub repository at androidfcd/sharp. And when you do, definitely watch, star, and fork this repository. That gives this language a lot more visibility and let other developers know this language exists. Also, if you're curious about learning what I do on a daily basis, you can head over to the remastered branch. And in there, I pretty much do my daily things with the language, and I typically do like a daily update. And I write some pretty decent commits, so you can kind of get a gist of what I've been up to without really having to look too much in the code. Also, if you guys are curious about learning maybe some of the things that I've done in the past to the language or stuff that I'm looking to add in the future, you can head over to the docs folder, and there's two main files. There's the changeless file, which basically holds everything that I've done to the past in the language, and the roadmap file, which contains all of that information as well as stuff that I'm looking to add in the future. Also, if any of you guys are looking to see what I've been up to recently, I've just recently published 0.2.805, which is the next and the last version before 0.3.0. This is a major update, which basically encompasses all the things that we're going to be learning in this YouTube series, and it contains a ton of stability improvements and just a ton of various different things. This is the second version of my compiler that I've developed. So I definitely recommend you guys checking this release out. You can head over to the main portion of the project and you can head over to releases and you can download the zip file there. So hope you guys enjoyed the video. As usual, if you're new to the channel, definitely consider subscribing, and until next time, I'll see you guys later.